So in this lesson, we're going to revisit step and piecewise functions, something that we've seen earlier. Okay, and they are just as what they are described. So we have what the Postal Service is charging us for various weights of whatever we're mailing. So our x-axis is our weight in ounces. Our y-axis is our cost. So that we see that our weights are going in increments of 8, because we want to make sure we get all the way up to 80. And then we're going to have a little bit of a break here because our costs, we're going to count by, we're going to start at 1175 is our smallest, and we're going to count by ones from there. Make sure we get up to 24. Okay, so this is going to be a stepwise function because we have a fixed amount over a particular range of values. So from 0 to 8 ounces, it's 1175. So we're somewhere around here. We're going to have an open circle going out to 8, which is closed. Remember, you can't have an open and closed circle over the same number. At 8 ounces, it goes up to 1575. Okay, so we're somewhere around there. That's open until we get to 32, where that's closed. Then we go to 1850, so that's open somewhere around there. From there until 48, which is here. Then we go 2125, which is a little bit above there. You can see correctly through 64. Okay, these circles are open. It's a little hard to see. Okay, but the top circle above the number is open. And then lastly, it's 24 from 64 or above 64. So I could draw a little bit better up to there. Okay, so that's an example of our stepwise function. Now, a piecewise function is just simply made up of pieces, okay, of if it's linear segments, etc. So Mateo is walking to school, so we have a situation where he starts at home and he's going at a constant rate. So after walking 9 minutes, he's 6 blocks. So 9 minutes here, 6 blocks there. Since it's a constant rate, it will be a straight line. He stops to rest, to text his mom for 5 minutes. So through 14, he's there. And then he goes at a constant rate until he gets home after 20 minutes, which is there. Okay? So from 0 to 9, he went 6 blocks in 9 minutes, or he went 2/3, okay, 2 blocks for every 3 minutes. So distance equals 2/3 times t. Then from 9 to 14, right, what we see is his distance is 6. It's a constant, okay? And then for the last interval, you got to be careful because it's going sloping down, all right? So we see that he went an extra 6 blocks. It took him 6 minutes, but it's a -1. So now we know d equals -t plus some number. So if I plug in a value for d and for t, I see that b is equal to 20. So d equals -t plus 20. Okay? And again, what that means is that 20 is what he would have, if he started at 20 blocks, okay, then that's how you would get to that constant rate and that final ending point. All right, now we have another piecewise function. From 1 to -4, I have this rules. So -4 is my smallest value. So when x is -4, y is -4. So I'm going to start there. And I have a slope up 2, right 1, up 2, right 1, up 2, right 1. And I'm going to do this until I get to 1, because at 1 I'm at 6, which is up here. And that has a closed circle, no arrows. At 1, I would have expected to answer 5, so I put my open circle there, and then I just continue down until I get to 5, 1, which is right there. I don't connect anything further, okay? What's the range? My range goes from -4 to +6, okay? Now, looking at my pieces here, if I wanted to figure out my slope, the slope of AB, 3/2, BC is 0, and CD is -1/2. Okay? Now, I want to find the equation of each of these lines. So the first one's going to be y equals 3/2x plus 6. This is just y equals 3. And this is y equals -1/2 x plus 4. Okay? Again, what you can do is take any point on those lines, plug them in to find b, or you can continue the pattern. Okay? So, for example, for AB, if I go 1, 2, 3, 2, there's my y-intercept of 6. If I continue here, my pattern of up 1/2, there's my y-intercept of 4. Okay? Now, writing this as a piecewise function, all right, which is pretty elaborate, I would write f of x equals, or just f of x, for 3/2x plus 6 from -6 to -2, but it doesn't include -2. Okay? And I'll explain in a moment. 3, it's from -2 to +2, and for -1/2 x plus 4, it's 2 to 6. Now, I could do this a little bit differently. What you need to see is when I go from here to here, only one of them can have an underline. In this case, it's either one works, okay? Now, why does setting the formula for this function equal to 0 not produce a viable 0 for that, okay? So if I set a -1/2 x plus 4, if I set that equal to 0, then x is equal to 8, which is outside my domain. Okay. Okay. What parameter in the piecewise linear model indicates that the function is decreasing? It's because the slope is negative. Tells you have a decreasing function. All right. And then last example, so I have my my step function here. So if my weight is 2 ounces, it's going to cost me 48 cents. If it's 2.2 ounces, it's going to cost me 50 cents. If it's 3 ounces, it's 50 cents. 3.5 ounces, 52, and 4 ounces, 52. If it cost Trina 0.54 to mail her letter, how many ounces? It would have to be anywhere from greater than 4 to less than 5 ounces. Okay, so that's our step and piecewise functions.